Good morning, students. Today we are going to see the next topic from Unit 4, that is Algebraic Approach to Image Restoration. So here we will be dealing with image restoration, and then after that we continue with for image restoration we need to create a degradation model and corresponding restoration methods. All these things we will be discussing here. First, we can see what is meant by image restoration. Image restoration is the operation of taking a current or IC image and framing the expected possible good image like original image. So, image restoration is performed by reversing the process of degradation. Actually, it is the inverse of degradation function. So, to create a restoration filter, we need to find out the degradation function. As referred, image restoration after to restore images that have been degraded. So when we are saying the things, that is first it identify the degradation process and attempts to reverse it. So when we are seeing about this, almost similar to image enhancement, but more objective. So when we are saying about it, it is more objective. So here, when we are seeing the picturization, this is a degraded image due to noise. After restoring, the image is very clear. So like this, improvement of quality will be carried out in image restoration. So now to find out the restoration rate degradation function is required. So how to find out the degradation function? When we are saying about finding out the degradation function, there are three principal methods are there. One is estimation by observation, then estimation by experimentation, and then estimation by mathematical modeling. So like this, different methods are there. Different methods are there to estimate the degradation function. So when we are saying about estimation by degradation method, here it is estimated visually by looking into the small section of image containing simple structures. So this, when we see about the estimation by observation, so that's the original image and degraded image. When we are seeing the difference by observation, we can find out. So this is a variation in like that it can be understood. Other variation can be restored. A variation can be restored back to produce a similar image like original image. We can say that image as restored image. So next we are saying about estimation by image experimentation. So here different approach, different degradations were taken into consideration, and corresponding restoration filters are also designed. So here it is expressed using images. So when we are saying about the earlier in digital signal processing system, when they create a system, they will be test the signal. You test the system using different test signals like sinusoidal signal, impulse signal, cosine signal, ramp signal. Like this, they will be testing the system using signals, and they will analyze the function. Like the same way here also, with the help of signals, they will carry out the experiment. It correspond to that. Here we will be using a impulse signal to carry out the experimentation. So next we are seeing about estimation by mathematical modeling. When we are saying about estimation by mathematical modeling, the degradation is modeled with correspond to mathematical model, because when we are seeing different applications of imaging, various applications, different waveforms are used at various comes to capture the image. So we can see the atmosphere, the object and camera in different applications can object camera and the atmosphere between them vary the varies. So here the atmospheres or different atmospheres have earlier itself they would have defined this. So that mathematical expressions can be used here to model a degradation function. So in such a way, if a mathematical model is said, we can say estimation by mathematical modeling. So when the degradation is modeled, it can be either represented in spatial domain. It can be represented either in spatial domain, like with the help of convolution, and in frequency domain with the help of product, we can express this. Or if you want to express in matrix also, you can express in such a way. So when we are seeing about the earlier distance phenomena, see noise models are there and corresponding mathematical mathematical formulations were there. So the corresponding the currently the degradations in image also can be referred with the correspond to noise models. So when we are saying about this uh, the noises are modeled with the help of probability density functions, and with the correspond to them, we can classify that is Gaussian due to poor illumination, Rayleigh due to range of imaging, gamma exposure due to laser imaging, impulse faulty switch during processing. So like this, we can classify the uh, degradations with correspond to noise model. So next we are saying about the restoration methods. Restoration is carried out with the help of filters. Major degradations in the image due to noise rest are compared to the effect of noise, it will be less. So when we are classifying the restoration methods, it can be the restoration is carried out with the help of filters. When we are classifying this, it can be classified as mean filters or median filters. So based on mean filter A, it can be further classified to arithmetic mean filter, geometric mean filter, harmonic mean filter, harmonic mean filter. Like this, we can classify this mean filtering. And when with the correspond to median filtering, if you are median filtering, if you are classifying this, we can classify this median filtering or max and minimum filters and midpoint filters. Like this, we are having different classification of mean and median filters. So when we are saying about these filters, the upgraded version also can be said. That is with correspond to adaptive nature. That is adaptive local noise reduction filter, adaptive median filter. So, like this, in different approaches, the restorations were carried out. Here, when we are seeing about in the restoration, the mean and variance are the simplest transformations which is being used. So when we say about a mean, it gives a measure of the average grayscale level in a local area, and variance gives a measure of the average contrast in the region. So this is the scenario when we are saying about this noise reduction filters. Finally, when we are seeing about the restoration, the filtering, the notch filters plays a vital role. When we are seeing about this, what we will call it as notch filter, the band reject filter with narrow band. The band reject filter with narrow band, we can say it as notch filters. This helps to remove the unwanted signals or noise in the system effectively. So, thank you. Okay.